Hey guys, Dr. Thomas. This is finish up chapter 1 here. We are on slide 25 of the chapter 1 PowerPoint. In this section, I'm going to be working problems, so instead of showing the PowerPoint, I'm just going to talk about the PowerPoint and actually work problems on the board. Slide 25 starts out just introducing the metric system. We definitely need to know our basic units of the metric system. Like if we're measuring distance, our base unit that we use is meters. You can add prefixes to the meters, like centi and kilo, to change the magnitude of the value. So you guys need to be comfortable with those prefixes, as we said before. But anytime we're given in this class a unit of distance that's in either feet or inches or miles or whatever else, we will commonly have to change that into the metric unit of meters or some variation off of that. So we have to be comfortable with those conversions. Also, when we deal with volume, our base liters can be liters, but again, sometimes we will use milliliters a good bit. And then if we get to mass, we prefer to have grams or kilograms. When we have time, the units of time are normal, either seconds, minutes, hours, any of those are fine. When we go to temperature, there are 3 temperature scales that are used in everyday life. Fahrenheit is the one that we use the most in the United States, but we are the only ones in the world that do that. So honestly, in science, Fahrenheit is never an acceptable temperature scale. So you will have to use the equation, and it's on the bottom of slide 25. You have to use the equation a few times in Mastering Chemistry and in the Introduction to Math Lab, just to demonstrate that you can change Fahrenheit to Celsius and back and forth. But generally, I will not put that on the test. It's not an equation I expect you to memorize. Just show that you can use it on the homeworks and stuff like that. But what you do need to be able to do is change Celsius to Kelvin. That is something that comes up a lot. The best temperature scale is Kelvin. It's called the absolute temperature scale, where if the temperature in Kelvin is 0, and you don't use the word degrees with it, but if it's 0 Kelvin, that means that the energy of the particles is 0. And that's the point where all movement of particles stops. So that's called absolute 0. Then in Kelvin, at whatever temperature you have, if you double the temperature in Kelvin, that corresponds to doubling the kinetic energy. So the Kelvin scale is the one that corresponds the most closely with the amount of energy of the particles. It is the best temperature scale to use, but there are a lot of times in this class that Celsius is okay. When we use Celsius, if we talk about 0 Celsius, Celsius was kind of arbitrarily, they decided to set 0 Celsius to be the freezing point of water, and 100 degrees Celsius is the boiling point of water, and then they've broken into 100 increments in between, so it's kind of random how they set that. But the size of a degree in Celsius is the same size as not a degree, but 1 Kelvin unit. So the nice thing is, if we warm up a sample by 10 degrees in Celsius, if we were to switch to Kelvin, the change in temperature would still be 10 Kelvin. So that the fact that they correspond to each other that way helps make a lot of calculations that we do. We can use Celsius or Kelvin and actually work it out, because a lot of times we're dealing with the change in temperature rather than the temperature itself. Okay, but you have to deal with that on a case-by-case basis. As we go through the semester, I'll usually tell you as you work a certain problem, this time we can use Celsius, or this time we need to use Kelvin, or whatever. Okay. Anyway, so that's slide 25. Now slide 26, we get into problems. I'm going to read each problem and then start to work it. So the first problem, a woman has a mass of 115 pounds. What would her mass be in grams? So basically, anytime I start a problem, I'm going to start out by putting the numbers that they gave me on the left, and then whatever it is I'm trying to find on the right. Okay, and in between, and I put the value they gave me, I leave space to do conversions, and then I put it equals the answer. Okay, on any test, you should write that down immediately. Like, figure out what number you should start with, put that over here, put the answer over here, and leave your space for your work before the equal sign. Okay, sometimes students start working, and number one, they'll look at a problem and just stare at it, and they don't write anything down. Well, if you don't write anything down, you're never going to figure anything out. And then number two, they'll mess up and like put the equals over here, and it's like, okay, we have a number, but then it equals, you haven't done any work yet. So we need to have our equal sign over here by our answer. Okay, so that's just a general setup. And then to convert from one unit to another, if you know the relationship between those two units, then you can do a single conversion to go from the first one to the second one. Okay, sometimes that's going to work, that makes it an easy problem, but then there are going to be cases where you have to go through a series of steps to get from the beginning to the end, and then you're going to have to do multiple conversions in the middle. Okay, so in this case, if I want to go from pounds to grams, that is not a conversion I expect you guys to just know. It's one that would be provided. If you look in the in D2L, in the spot where the syllabus is, which is under the Start Here icon, I have the syllabus. I also have a formula sheet. That's the formula sheet that in a normal class, when we take a test, that's provided with the test. It has a set of common conversions on it that you don't need to know, but they're provided, so you need to use them when you need it. Okay. One of the conversions on that page is the relationship between pounds and grams. I think it says something like 454 grams equals 1 pound. Okay. Now, it might actually have more significant figures in it, but I'm just rounding off because that's what I know in my head. So that's the relationship between grams and pounds. I'm going to use that and make a fraction out of it. And if it's a fraction where the 1 pound and the 454 grams, they're equal to each other. So if I make a fraction where I put one on top, one on the top and bottom had the same innate value. So the overall value of that fraction, if it's the top and bottom are the same, it equals 1. That's called a unit factor, and basically I'm going to multiply my starting number by that fraction. And if I multiply a number times a fraction where its value is 1, I'm really not changing the overall value of what I started with. I'm just going to shift the units from one unit to another. Okay, so the way I do that, I'm going to take this and make a fraction. I specifically want to get rid of the units I started with. So the pounds I started with, I want to get rid of it, so I'm going to put the 1 pound in the bottom. Because in math, anytime something appears in the top and the bottom, you can cancel it out. And that's going to put the 454 grams in the top. But there'll be cases where I use the same relationship where these may flip, okay? I always have to decide which one goes on the top, which one goes on the bottom. It's based on what I'm canceling out and what I want to end up with. So right now I can say pounds, cancel pounds. In my calculator, I would just multiply 115 times 454. And I would get 52,210. Okay, now if I write down that number as my answer, I'm going to lose points because the number that was given in the problem, and the problem only gave me one value. It gave me 115 pounds. I have to recognize that's 3 sig figs. And then when I look up a conversion, and I'm looking up in some outside source that wasn't part of the problem, I have a responsibility when I look up a conversion, it needs to have at least as many sig figs as the number that was given in the problem. This is the measured value that was given in the problem. It has 3 sig figs. Honestly, I would prefer when you look up a conversion, you want it to have more sig figs than the numbers that were provided in the problem. If you don't do that, then what happens is anytime you round something too much, and if this only had 2 sig figs, it means it's been rounded too much compared to my original number. That's going to actually change your answer a little bit. And again, mastering chemistry or on your assignments and stuff, there's a certain range of values that we'll accept. And if you round it too much and it pushes it outside the range, then mastering chemistry might count it wrong. Just remember, it's a computer program. It's following a algorithm to tell it what the right answer is, and if you get outside of the range that it accepts, it's going to count it as a wrong answer. Okay, so this answer, I should round it to 3 sig figs because the math I did was multiplying and dividing. For multiplying and dividing, I go with the number that has the fewest sig figs. The only number they gave me was the 115, so that's the one I have to go by. So 3 sig figs here. I'm going to keep the 5, the 2, and the 2. The 1's going to get rounded off, so basically that 2 is in the hundreds position. So I'm going to round this number to the nearest 100. So it's going to end up being 52,200 grams. That is the right answer. Or if you prefer, you can put it in scientific notation and say 5.22 times 10 to the 4th grams. Either one of those would be an acceptable answer. I don't care. Sometimes students ask, when do you put something in scientific notation? Basically, if I look at a number, and if I had to sit there and count how many zeros there are, it's a difficult number to read out loud. That would be a case where you should put it in scientific notation. It could be really big or it could be really small. Either way, if it's difficult to read, then you need to put it in scientific notation. If it's easy to read, like 52,210, that's not a number that I necessarily think has to be in scientific notation, although I certainly won't count it wrong if you do it. Okay, so that's that problem. Now our next problem, a boy is 5.75 feet tall. How tall is that in inches? So now, essentially, at some point you have to figure out which conversions are you guys supposed to know and which ones are you not supposed to know. Okay? Well, here's the rule. If we're going to do 5.75 feet and we're going to inches, the relationship between feet and inches, that is a common relationship that if you grew up in the United States, pretty much everybody knows there's 12 inches in a foot. Okay? So conversions that are common values like that, I would probably expect you to know. Okay? You know there's 60 seconds in a minute, you know there's 60 minutes in an hour, that kind of thing. That's basic knowledge that everybody should have if they're in college. Okay? Then you are supposed to memorize the metric prefixes. Well, with the metric prefixes, you should know there's 100 centimeters in a meter. You should know there's 1,000 millimeters in a meter, and that kind of thing. So you should be able to do conversions between the powers of 10 and the metric system. You should be able to set that up and figure that out without any outside help. Okay? The values that I don't expect you to know are the ones that relate, like the problem we just did, where you have a metric unit and a non-metric unit. Where grams are metric and pounds are non-metric. That relationship is just a random value, and there's no need for you to memorize all those numbers. There's too many of them to deal with. So anytime you're going in or out of the metric system, that would be a value that will either be on the formula sheet, or if you're doing homework, you can look it up. Okay? The key here is, while you guys are taking tests in this class, especially if it's an online test, you'll have the ability to look up anything you want to online or in your book or whatever. The problem with that is it'll take time. Every time you have to stop and look information up, it's going to slow you down. And guess what? I'm not going to give you enough time on the test to look up everything that you need to. Okay? You have to know some of the information. You have to practice working problems enough so that you feel good about what you're doing and you can actually complete the problems in a timely fashion. Okay, so that's really the challenge that you guys are going to face, is practicing enough and knowing the stuff that you're supposed to know and not just relying on your notes or the textbook or on Google all the time. Okay, so let's work this problem real quick. Again, I know the relationship between feet and inches. That's a single step relationship, so I can just write my conversion. It's 12 inches in a foot. The one I'm canceling goes in the bottom, so I'm going to put the 1 foot in the bottom and the 12 inches in the top. If I multiply those together, should come out, I think it's 69 inches. But again, I need to think about, my calculator is going to give me that exact number. But I need to think about sig figs. I was given 3 sig figs in the beginning of the problem, and I did multiplication. This is a defined relationship, so it's not limited by sig figs. This is technically like 12.0000 over 1.0000. So don't let the conversion here affect your sig figs. The measured value was this one. 3 sig figs, multiplying and dividing. I need to have 3 sig figs here. So actually my answer ought to be 69.0 inches. That's the answer you should report as your final answer. Okay? So I'm going to cut off the video, probably have one more after this one.